Hello everyone. So, till now we have studied about charges, electric fields, and superposition principle. Now we are moving ahead with a new term called dipole. In this lecture, we are going to study about dipole, dipole moment, and what is the electric field at the axial line due to an dipole. Then we will see one or two questions in this lecture. So we are starting with the concept of electric dipole. Electric dipole. So what is an electric dipole? Electric dipole, first I'm going to define it. Electric dipole is two equal, equal in what? Equal in magnitude, equal and opposite, opposite charges separated by a separated by a certain distance is called a dipole. How it looks like. So, for example, this is plus 5 nanocoulomb. This is minus 5 nanocoulomb. So both these charges are separated by a distance. So the separation between them is called 2L. For now, for this case, we will call it 2L, right? So the dipole, the two charges are separated, and there are two poles, and both are equal in magnitude. If you see what is the magnitude of 5 nanocoulomb minus 5 nanocoulomb, it is 5, right? 5 nanocoulomb. So the magnitude is equal, but they are opposite charges. One is positive, one is negative. So, so electric dipole is what? Two equal in magnitude, but opposite charges. That is separated by some distance, that is an electric dipole. Now, if I ask you, just a very small question. If I ask you, is it is it a dipole? I'll give you the question. Is it a dipole? The figure is okay. The figure is minus 3 nanocoulomb and 5 nanocoulomb. Does it represent a dipole? Yes. They have negative and positive charges, but magnitude magnitude is not equal, right? If magnitude is not equal, it doesn't represent a dipole. So this is not a dipole, not a dipole, right? Clear? Now we will come to next thing, dipole, dipole moment. How we define it? First we will define it, then we will see what it represents, how it represents, and what does it mean. So first dipole moment, the product, the product of either charge and the separation between the two charges. That is our dipole moment. Represent by, it is represented by a letter P. So how we define it? P is equal to Q, any charge, into 2L. Suppose my dipole is this. This is plus Q charge, and other one will be, of course, Q minus Q. So they are separated by a certain distance, that is your 2L. So this is your dipole moment. But This dipole moment is a vector quantity. It is a vector quantity. If it is a vector quantity, it must have some direction. So the direction of dipole moment is from negative to positive charge. That means it is opposite to, I can also write it, it is opposite to electric field. It is opposite to the electric field. So the dipole moment direction is opposite to the electric field. Right? Clear up to here? Now, so understand about dipole. What is a dipole moment? So dipole moment is written by letter P. It is going from negative. The direction is from negative to positive. Right? So now, what? Hope you have written up to here. Now, the next step we are going to discuss our main topic, that is electric field at the axial line of an electric dipole. Electric dipole. Now, but first, electric dipole, we know what is an electric dipole. But what is an axial line? Line, what is axial? So first we will define axial line. Axial line. Let's see. The line which passes through the two poles of the dipole. Through the two poles of the dipole. That is our axial line. What does it mean? If I draw here, okay, I'll draw it here. If I draw here a negative Q charge, and here I draw a positive Q charge, we know both are separated by a distance of, what we say it, 2L. Then the line, this line which is passing through the two poles, that is our axial line. It is at the left as well as it is at the right. If you want to draw to the left, it will also come to the left. Right? It is coming through both ends. Means we switch, we take it to the other side. Yeah, at the center. If I put it at the center, that means this all is an axial line. This whole thing is our axial line, the dotted line which is passing through both the poles of the dipole. That is your axial line. So this line is your axial line. Suppose someone asks me, so at this point I choose it as P. What is the electric field at this point? If someone asks me what is the electric field at this point on the axial line, so how to calculate it? I take the central point, that is, this is the center of the dipole. If I consider, then I always consider from the center of the dipole at a point P where I'm going to find the electric field is at a distance R, right? Now, so the positive charge is at what distance? Because I am taking it from the center, so my this distance will be L, and my this distance will also be L, right? Both these distances are L. Now, so what is the distance from the plus Q to point P? What is this distance? Yeah, it's very easy. You know it is R minus L. And what is the distance from negative Q charge to point P? That is very easy also, R plus L. Right? That is a very easy. You can find out the distance. Right? It's simple mathematics. Clear. Now, We know superposition principle. So if I say electric field, electric field at point P due to positive charge. You are aware about the formula, right? What is the formula? QQ by R square. So for positive charge, I'll just put E positive, just a representation that this electric field is for the positive charge. So I'm just putting a plus sign. So what is the formula of electric field? K charge. And what is the distance? R minus L, right? R minus L whole square. That is the electric field, right? Now, if I say this positive charge push this point P, because point P is what? Point P is always we are considering a unit positive charge. So if it's the unit, what is a unit positive test charge? Unit positive test charge is that charge which is very, very, very small, right? That means that doesn't impact the plus Q charge and the negative Q charge. Clear? That is a unit positive test charge. Now, plus Q and plus Q will repel. So it will move to this direction. So this is the direction of E positive. Clear? And on the other hand, if I want to see the direction of the other one, negative, because it is a negative will attract E negative. What is E negative? E negative same. Electric field at point P due to negative charge. So that will attract. If this is a point P, this is negative charge, it will attract this, right? So next thing, electric field. If I want to write electric field at point P due to negative charge, what I can write? E negative will be negative K Q by R plus L because the distance is plus. So I can put plus L square, right? Now someone asked me, sir, why Q you are not taking negative? That is a negative charge. We are in this, we are not taking the sign of the charge because if you see the formula here, I am not putting vectors. Electric field, I am not putting vectors. If I put vectors, then I have to consider the sign of the charge. But I am considering the magnitude of electric field. I'm considering the magnitude, then it will remain positive, right? That's why I'm not using the sign of the charge, right? And one more thing I want to say, if we are considering the direction, then we don't need to worry about the charge. You always take it as the magnitude because we are already considering the direction in the picture, right? The figure itself. E positive is towards this side, E negative is towards this side. So we don't need to worry about the charge sign, right? You always take the magnitude. Now, next thing. This is the electric field we calculate. So what is the total electric field at point P? Total electric field at point P. Total electric field is generally what we say sum of. But here we don't use sum. Why? Because the direction of both is opposite to each other. So what we say the total electric field is E positive minus E negative. Right? So this is a total electric field. Now you just write down the equation of E positive. We know what is E positive. This is the value of E positive. This is the value of E negative. Right? Now I am going to solve it here. So total E will be K Q and taking it as a constant outside. What is left inside? R minus L whole square minus 1 over R plus L whole square. So what E will come? This is just a simple mathematics. So it will, if I take the LCM, R plus L whole square will be upside, and here R minus L whole square divided by, I'm using a formula A minus B and A plus B down. So what is A minus B, A plus B? That is A square minus B square. Because outside is already a square, so square is there. Clear up to here? Very good. So now we move to the next step. Just a simple mathematics. You open it up, it will become R square plus L square plus 2RL minus R square minus L square plus of 2RL. I am already multiplying that negative sign inside. I hope it is clear. It's simple mathematics which you are aware about. So what you will get? A, Q. Look, if I say this will get cancelled out with this, L square and L square will get cancelled out. So what you will get? You will get 4RL over R square minus L square power square, right? And we know that we can write it into, if I break 4 into 2L and make it 2R, we can write it into P. But who is P here? Can someone tell who is P here? Yes, exactly whatever you're thinking. Q into 2L is your P. That is your dipole moment, which we have just studied. So 2, I'll take it here. I can write R. So 2 kpr over R square minus L square whole square. So this is the electric field. I can just write it again. 2 kpr over R square minus L square whole square, right? So this is the electric field due to an axial line, and you have to remember this formula. Okay. Now there is a special case. What is the special? Why there is so special about it? The special about it, if R is very, very larger than N, then what happens? That means R square is very, very larger than L square. That means L square is very, very small. If something is very, very small, we can of course ignore it. If I ignore L square, then what should I get? I'll get R square square. That means I will get 2kpr over R4. R and R would cancel out. E is equal to 2kp over R cube. So this is what we say, electric field due to a short dipole. Right? This is the electric field because of a short dipole. So this formula we are generally using. This formula we will use a lot of time. So remember that E is inversely proportional to R cube. P is your dipole. Correct. What is K? Yeah, K is 1 over 4 pi epsilon naught. Value of this is, I know. Till now you are already aware about all this. Units, Newton, meter square per coulomb square. Very good. These all things you are aware about. Good. Now, I'll give a very small question based on it.